It's probably the second of these two questions you've tuned in for, but let's just have a look at the first one first. So random error, as the name suggests, is kind of random, so it's all over the place. The bigger the spread is representing of a greater random error. Systematic, there's kind of a system to it, okay, so that all of the readings are out by a certain amount. It's the kind of thing that happens when you're measuring things with a set of scales and you forget to zero the scales at the start. Everything's going to overread. Or if you haven't calibrated an instrument, everything's going to be out by a certain amount. You can actually do something about that if you know kind of how far out that is. You can kind of recalibrate all of your readings. So LabSonic, you can see it's got the biggest spread there, so that's going to have the most amount of random error. If I take a visual mean of that one, sort of like average it out, and I average out this one, you can see that the MaxLab has the greatest amount of systematic error. But I'm going to guess it's actually the second question that's causing you the most amount of concern. And it's possibly because you've read it in a textbook or seen it online somewhere that repeating an experiment over and over again increases the reliability. It doesn't. Let me explain. Let's say that you're going to catch the 8:15 bus and you turn up on Monday and the bus is there at 8:15. Is that a reliable bus? Well, you don't really know at this stage. So you turn up Tuesday morning and it gets there at 8:10. You barely made it in time to catch the bus. The next day it turns up at 8:30. After that it turns up at 8:25. And the day after that it's back there at 8:15. Getting more information doesn't make that bus more reliable. Repeating an experiment doesn't make the data more reliable. What it does do is it gives you information about how reliable the bus is. When you only went on Monday, you kind of like, maybe it's reliable. You need to turn up over a number of days to see the randomness, to see how much that data spreads when I repeat the experiment and take the next measurement. So that definitely eliminates the option that's about making the data more reliable. I read about an experiment where they showed farmers a cow and got the farmers to estimate the mass of the cow. And the more farmers they got to estimate the mass of the cow, when they averaged all of their estimations, they got closer and closer to the actual value of the cow. And that's how random error is. When you've got a very small sample set, 2 or 3 samples, then one kind of randomly high or randomly low value can drag it off. But by having lots of them, you average out that random error.